This is going to be the Unit 9 test review for 8th grade. Taking a look at number 1. It says the cylinder has a diameter of 22 and a height of h. Which equation can be used to find the volume of this cylinder? First thing that you need to do is to go to your formula chart. We know that we are dealing with volume of a cylinder. So looking at my volume formulas, I know that V equals area of the base times the height. Because again, that I'm dealing with a cylinder, I know that my base is going to be a circle. And to find the area of a circle, it's pi r squared. And then I would have to multiply that times the height. From here, I'm going to plug in the numbers that I know. They tell me that my diameter is 22. So if my diameter is 22, my radius is half of that. And they don't give me a height, so we're just going to stick with h for the height. From here, I just plug in my numbers. So pi, I'm just going to leave it as pi. My radius is now 11, so I would do 11 squared times the height. There's only one over there that looks like it might come close, and it's d. But the problem is that 11 is missing the squared. And because it doesn't have that, d is actually out now. So I know that 11 squared is 121. So this over here is the same thing as pi times 121 times h. So looking over there, the only one that actually matches is going to be B. Taking a look at number 2. The height of a cylinder is 9 centimeters. The circumference of the base of the cylinder is 10 pi centimeters. Which measurement is closest to the volume of the cylinder in cubic centimeters? I know that I'm working with volume of a cylinder, and again, my formula for volume of a cylinder is going to be V equals area of the base times the height. Now here's the problem with this one. They gave some kind of funny sounding information. They said that the circumference of the base of the cylinder is 10 pi centimeters. To be quite honest, off the top of my head, I'm not sure what to do with that, but I know what I'm talking about, circumference, and I know it's pi times 10 times pi. So the formula for circumference, I'm just going to write it out. It's C equals pi times diameter. Well, if the circumference is that, they're telling me that the circumference is 10 times pi. Well, I know that my diameter of the circle is now 10. So if my diameter is 10, I know that my radius is going to be 5. From here, I'm just going to go back to my classic volume formula. For area of the base, I have to use pi r squared because it's a circle, and then we'll do that times the height. And again, it's pi r squared, pi times 5 squared, and the total is that our height is going to be that 9 centimeters. Then I can just plug these into the calculator, and I get 706.5 centimeters cubed. Now, there's not, because there are different ways to use pi, you could use the pi button or 3.14. This is going to be the closest answer of D on number 2. Taking a look at number 3. Beads are sold in a cylindrical container with a diameter of 15 centimeters and a height of 6 centimeters. How many cubic centimeters of beads does this container hold? So again, they told me cylindrical container, so I know that I'm dealing with a cylinder. They give me the diameter of 15 and a height of 6. And wants to know cubic centimeters, so I know I'm dealing with volume. So again, volume formula for a cylinder is V equals area of the base times the height. The area of the base is for a circle, so we use pi r squared. And then we would do that times the height. Now I'm going to start plugging in the numbers that I know. They told me that the diameter is 15, which means my radius is half of that, so it would be 7.5, and my height is 6. So I'm going to do pi times that 7.5 squared times my height of 6. And then I get 1059.75 centimeters cubed. Times that to B. On to number 4. Maya has an exercise ball in the shape of a sphere, so I know what shape I'm dealing with. She wants to increase the weight of the ball by filling it with water. Which value is closest to the amount of water in cubic inches that Maya's exercise ball will hold if it is completely full of water? So if I'm filling the ball, I know that I'm dealing with volume. And looking at the formula chart, the formula for volume of a sphere is 4/3 pi r cubed. Now on this one, they're giving me, this goes all the way across, so the diameter is 26, but I need a radius. Radius is half of that, so my radius is going to be 13. From here, I just plug these things right into the calculator. So I'll do 4/3 times 3.14, or pi, whichever button you want to use, times 13 cubed. And you get 9,198.1. Yeah, technically mine's 1,1. So again, I'm going to look at for which one of these is closest. Closest answer is going to be A. And just so you guys know why my answer is off, I used the 3.14. If I'd actually used the pi button itself, I would have gotten a more exact answer of what A has. Taking a look at number 5. A gardener has a cylindrical planter, so I'm going to underline that has a diameter of 12 and is 25 inches deep, so that's essentially our height. What is the approximate number of cubic inches of potting soil that she will need to fill the planter? So we're filling it. We know we're talking about volume. And volume of a cylinder is area of the base times the height. Things that we know, they told us that the diameter is 12. And if my diameter is 12, I know that my radius is going to be 6. And that depth will essentially be our height for this thing, so our depth is going to be 25. Again, area of the base, because we're dealing with a cylinder, is a circle. So it's pi r squared times the height. So we're going to do pi times 6 squared times 25. And I get a value of 2826 inches cubed. Closest answer on there is going to be C. Number 6. Roger has a bowl that is in the shape of a half sphere with a diameter of 15 inches as shown below. What is the volume in cubic inches of the bowl if it is completely full? So a couple things that we need to take note of. We're dealing with a half sphere, so we'll have to divide our final answer by 2. So again, the formula for volume of a full sphere is 4/3 pi r cubed. They told us the diameter is going to be 15 inches, which means our radius has to be 7.5. So again, I would just plug this into the calculator. And I would get a value. When I do that, I get 1766.25. Now that's the value for a full sphere. So I'm going to divide this answer by 2 because I'm dealing with half of a sphere. When I divide by 2, I get 883 and some decimal numbers. Closest answer on there is going to be B. Taking a look at number 7. Macy's designing a new fish tank that is shaped like a triangular prism with lateral faces made of glass. The bases of the prism are right triangles. Macy's new fish tank will look like the diagram shown below. What is the lateral surface area of Macy's fish tank? Lateral surface area of a prism, if I'm talking about lateral surface area, I would look at my formula chart and I know it's the perimeter of the base times the height. So the triangle is down here on the bottom. They told me it's a right triangle, which might have been useful if we were dealing with total surface area, but we don't necessarily need that. Our perimeter is the distance all the way around the bottom of that triangle. So it's the 9 plus the 12 plus the 14. So we get a total perimeter of 35 inches. Our height is the distance between the two triangles. So our height is going to be 12 inches. From here, I can just plug in what I know. Perimeter of the base is 35 times that height of 12. Now I do 35 times 12, and I get 420. So our answer would be B on number 7. Number 8. A hollow cylinder, so I know what shape I'm dealing with, is made completely of plastic material. It does not have a top or bottom. What is the lateral surface area of the hollow cylinder? So I would look at my formula chart for lateral surface area of a cylinder, and it is 2 pi r h. Well, we know that our radius right here is going to be 7. We know our height is 14. So we just plug in numbers. So we do 2 times pi times my 7 for my radius times my 14 for my height. We get 615.44. Closest answer on there is going to be C. On to number 9. The rectangular prism shown below needs to be painted on all sides. And we're covering the outside. How many square centimeters of paint is needed for the prism? So we're talking about not lateral, we're talking about total surface area because we are doing all sides. When we talk about total surface area of a prism, we use the formula PH plus 2B. Numbers that we are going to need to come up with first is we need to know what P, H, and B are, and then we can just plug these into the formula. So I'm going to look at the base here. I'm going to call this rectangle down here on the bottom the base. And I know that the sides are going to be the 6, that 4, this is over here going to be 6, and this over here is going to be 4. So to find my P, or the perimeter of the base, I'm going to add those sides up. So I'm adding 6 plus 4 plus 6 plus 4. Pardon that really terrible handwriting. So I'm going to add these up, and I get a total of 20. Now my height is going to be the distance between the top and the bottom, or the two rectangles that I'm calling my base. So my height is 5. Now for big B, I'm talking about the area of the base, or the area of that rectangle on the bottom, in which we just do base times height. So looking at just the rectangle on the bottom, we have a 6 and a 4. So we are going to do 6 times 4 for the area of our base. 6 times 4 is 24. Now I'm ready to just plug in my numbers. P, perimeter of the base, we know is 20. We're going to multiply that times, H, we know is 5. We already figured that part out. Plus 2 times the area of our base. The area of the base we already figured out is 24. This part we can just plug into the calculator and we get a total value of 148. That'll be centimeters squared. So answer is going to be D. Taking a look at number 10. Bob is constructing boxes in the shape of a triangular prism. How much cardboard is needed to make each box? So if we're going to make a box, we're not filling this box up. We're just building the outsides of it. Therefore, we are going to have to do total surface area in order to build this box. So again, our total surface area formula is going to be PH plus 2B. And I need those numbers before I can go any farther. I need P, H, and B. P is the perimeter of the base. So I'm going to use this one over here because it's got the right angle on there. To find the perimeter, I'm going to have to add the 3 sides of that triangle. Those 3 sides are 6, 10, and 8. When you add those sides, you get 24. And our height is the distance between the 2 triangles. This distance right here. So I'm going to do 15 for my height. And now for the area of the base, I'm going to look at the right angle on the triangle. I have to multiply the 2 sides that are attached to that right angle and divide by 2, because the formula for area of a triangle is base times height divided by 2. The base of that triangle is 8. The height of the triangle is 6. We're going to divide that by 2. 6 times 8 is 48. Divide that by 2 is going to be 24. So now we have all the numbers that we need. For perimeter of the base, it is 24. The height is 15 plus 2, because that's where that comes from, times the area of the base, which is 24. And again, this part I can just plug into the calculator. And I get 408. That'll be centimeters squared. C. Number 11. Mr. Suarez wants to paint his storage shed. He needs to calculate the lateral surface area of the shed so that he will know how much paint to buy. His shed is in the shape of a rectangular prism with the dimensions shown below. Including the doors, what is the lateral surface area of the storage shed in square feet? So lateral surface area, the formula on a prism, is going to be P times H. Well, we need to know P and H before we multiply those two together. The base is really down here on the bottom. It's a little bit harder to see because they didn't give us a see-through figure this time. but I know that it's going to be 15, 8, 15, and 8. So I can add those up and get my perimeter. So I've got 15 plus 15 plus 8 plus 8. And I get a perimeter of 46. My height is the distance between the top and the bottom, so it's 10. And then we just plug this into our formula. The perimeter is 46 times the height is 10, and you get 460. That's feet squared. So A. Number 12. The diagram below shows a cone and a cylinder that have congruent bases and congruent heights, meaning same radius, same height. Which statement, where h represents the height of the cone and the height of the cylinder, is true? Before I bother reading these, I want to talk about volume, because just looking at the answer choices, all of these have something to say about volume. So, for a cylinder, volume is equal to area of the base times the height. For a cone, its volume equals 1/3 area of the base times the height. Okay, I know that those two are two different formulas. Essentially what that formula says is that the cone is 1/3 of the volume of the cylinder, meaning that I could fill this cone, if I did this cone and I had everything on the inside of it, the whole volume of it, I could put that cone into here 3 times. So now I'm going to read through the answer choices. A, the volume of the cone is 3 times the volume of the cylinder. Well, that's backwards. The cone is smaller, so that doesn't make any sense. A is out. B, the volume of the cylinder is 3 times the volume of the cone. Well, that's what we said. And C, the volume of the cone and the volume of the cylinder are equivalent. Well, clearly they're different sizes, so C is out. D, most of the time answers are going to be there, so don't mess with not here answers. So our answer is going to be B. Number 13, a fishbowl shaped like a sphere is filled with water. The fishbowl has a diameter of 16 inches, so the diameter is 16. Which measurement is closest to the volume of water, the fishbowl, in cubic inches? So we're dealing with a sphere. The only formula for volume of a sphere is 4/3 pi r cubed. Over here, they're giving us the diameter, so the diameter is 16, but we need the radius. Radius is half of the diameter, so the radius is just 8. So at this point, all I'm going to do is I'm going to change out my radius, or that r, for my radius of 8. And then I plug this in the calculator and get the number I'm looking for. And when I plug these in, I get 2143.57 inches cubed. And again, because I'm using 3.14 for pi, I'm having to round a little bit, so my answer is going to be A. Number 14. In a museum, there's a sculpture in the shape of a cylinder, so I already know what shape I'm working with. The cylinder has a diameter of 12 feet and a height of h feet. Well, that didn't help us, so I don't have anything to work with there. Which equation can be used to find V, the volume of the cylinder, in cubic feet? So again, this is similar to one that we did before. Volume of the cylinder is equal to area of the base times the height. Oh, and I meant to label the radius over here. The diameter is 12, the radius is 6. We know that big B is the area of the base, and the base of a cylinder is a circle. So area of a circle is pi r squared. Then we multiply by that height. Well, the numbers that we know that the radius is going to be 6. So I'm going to fill this out as pi times 6 squared times the height that we don't know. So now looking at my answer choices, there's only one that has 6 squared. So our answer is going to be A. Taking a look at number 15. A container is shaped like a triangular prism. Each base of the container is an equilateral triangle with the dimensions shown. The container has a height of 15 centimeters. What is the lateral surface area of the container in square centimeters? Well, because we're talking about a triangular prism, which I forgot to mark up here, I know that the formula for lateral surface area of a prism is P times H. They tell me that this triangle here is the base. So in order to find the perimeter of the base, I'm going to add those 3 sides. and I get a total of 18. They tell me over here that the height is 15 centimeters. So all I'm going to do is plug in my numbers. I'm going to do 18 times the 15, and I get a value of 33. That'll be centimeters squared because we're talking about area. On to number 16. Snacks at a county fair are sold in containers shaped like a cone or a cylinder. The dimensions of each are shown in the drawing. Which statement about the volumes of the cone and the cylinder is true? At a quick glance, it looks like we're going to have to find the volume of these. So for the cone, we're going to use the volume formula. V equals 1/3 area of the base times the height. So for the area of the base is a circle, so it's pi r squared. And then we need to multiply by the height. Here they are giving us the radius, and here they are giving us the height. So we are going to do pi times 4 squared times 12. Here I get a value of 602.88. Over here for the cylinder, it's going to be volume equals area of the base times the height. Again, it's a circle for the base, so we are going to use pi r squared, and then we multiply that by the height. Again, they give us the radius right here, which is nice, so we don't have to figure anything out, and they give us the height right here. So we're going to do pi times the 3 squared times that 8 inches. And I get a value of 226.08. Now I'm going to start reading through answer choices. A, the volume of the cylinder is about 377 cubic inches greater than the volume of the cone. Well, for it to be greater than or less than, I need to subtract the numbers that we've got. I'm going to take this volume, and I'm going to take this volume, and I'm going to subtract them. So I'm going to do 602.88 minus that 226.08. And I get a difference of 376.8. So that's pretty close to the number that they said. So it said the volume of the cylinder is 77 greater. Well, the cone's larger, so A is out. B, the volume of the cylinder is 377 cubic inches less than the volume of the cone. That looks pretty good, but I'm going to keep reading. C, the volume of the cylinder is 25 cubic inches greater. Okay, well, these two are dealing with 25, so both of those are going to be out. So our answer on this one is going to be B. Number 17. An architect uses a cylindrical container to protect their blueprints. The dimensions of the cylinder are shown in the diagram. Which measurement is closest to the total surface area of the container in square inches? So for total surface area, you have to look at your formula chart. For a cylinder, we are going to be using 2 pi RH plus 2 pi r squared. Right here, they are giving us the radius. The radius is 3, and our height is that 15 over here on this side. All we have to do are plug these numbers in. So in the calculator, we would type in 2 times 30.14 times that radius of 3 times the height of 15 plus 2 times 3.14 times the radius of 3 squared. And again, we can plug this whole thing into the calculator as it is. And I get 339.12, which is going to be closest to C. Final problem, number 18. A rectangular prism and its dimensions are shown in the diagram. What is the total surface area of the prism in square inches? Again, for total surface area of a prism, we use pH plus 2 times the area of the base. We need to find P, H, and B on this first. The perimeter, I'm going to use the very bottom as the base. So I know that I've got a side of 7.5, 5, 7.5, and 5. I have to add those 4 numbers to get my perimeter. So 7.5 plus 5 plus 7.5 plus 5. And I get a total of 25. My height is the distance from the bottom to the top. So our height is 6.5. And our area of our base, because we are dealing with a rectangle base, it's just base times height, which means we are going to do 7.5 times 5. We get 37.5. Now from here on, I can just plug in the numbers that I've got. Our perimeter is that 25 times the height, which is 6.5, plus 2 times the area of the base, which is 37.5. Again, from here, we just plug those numbers into the calculator. And we get 237.5, and this is going to be inches squared. Guys, if you're still struggling with this, please make sure you come to tutorials so I can help you out.